Welcome back, everyone. So, we are now in the last topic for human to computer interaction. Uh, in this video, we will discuss evaluation, inspections, analytics, and models. So, we will now, all of the knowledge that we've discussed in the previous videos will now come into one. Now, introduction. Most of the evaluation methods described in this book so far have involved interaction with or direct observation of users. In this chapter, we introduce methods that are based on understanding users through one of the following: knowledge codified in heuristics, data collected remotely, models that predict people's performance. So in the previous videos, we discussed how to collect data while the users are there, such as interviews, ethnography, questionnaire, etc. Now we will gonna collect data indirectly without the user's cooperation. None of these methods require users to be present during the evaluation, so they can be conducted remotely, synchronously or asynchronously. Inspection methods often involve a researcher, sometimes known as expert, role-playing the user for whom the product is designed, analyzing aspects of an interface and identifying potential usability problems. So this inspection method often or usually needs researcher or expert role-playing the users for whom the product will be designed, analyzing the aspects of the interface and identifying potential usability problem or UX problem. Analytics involves interaction logging, and A/B testing is an experimental method that uses data collected about people's behavior. Both analytics and A/B testing are usually carried out remotely. Predictive modeling involves analyzing the various physical and mental operations that are needed to perform particular tasks and operationalizing them as quantitative measures. So, this method requires or involves analyzing physical and mental operations that are needed to perform the interface, manipulation or interaction with the interface, and operationalizing them as quantitative measures. And then, based on that interaction that we get, we convert them to a quantitative measure. So later we will discuss how we get qualitative data from heuristics and then making them quantitative. So one of the most commonly used predictive models is Fitts law. So this Fitts law is a different type of this method, which is an indirect research or indirect inspection or evaluation from the user. So we have this as a model or predictive model aside from analytics and inspection. So we later we will get clarity on what that means. Inspections, heuristic evaluation and walkthroughs. So here inspections, there's two parts: walkthroughs and heuristic evaluation. So one of the attractions of these methods is that they can be used at any stage of a design project. They can also be used to complement other types of usability testing. Heuristic evaluation. In heuristic evaluation, evaluators, guided by a set of usability principles known as heuristics, evaluate whether user interface elements such as menus, navigation structure, sound, online help, conversational agents, and so on confirm two tried and tested principles. So in essence, these are a test to make sure that it conforms to the principle or tried and tested principles of usability. Now, these principles of usability are known as heuristics, and it's different for different interfaces. These heuristics closely resemble high-level design principles, such as making design consistent, reducing memory load, and using terms that users understand. So, as we've discussed in chapter 1, these are the consistency principles, and now we are actually testing it. So, if in chapter 1 or in the first part of this human to computer interaction video, we discuss the qualities usually common for a usable product. Now we will now test it. So it's like a more complete version of that first video. These heuristics closely resemble high-level design principles such as making, etc. Heuristic evaluation was developed by Jacob Nielsen and his colleagues in 1990 and 1994, and later modified by other researchers to evaluate other types of systems. The original set of heuristics for HCI evaluation were empirically derived from the analysis of 249 usability problems. So the original set for this evaluation or method came from 249 usability problems in 1994. An early revised version of these heuristics are as follows. Visibility of system status. The system should always keep users informed about what is going on through appropriate feedback within a reasonable time. Match between system and the real world. The system should speak the user's language with words, phrases, concepts familiar to the user rather than system-oriented terms. It should follow real-world conventions, making appear in a natural and logical order. So, this is the key that shows up time and time again with human to computer interaction, in which we should design in natural way, meaning that it should mimic these everyday things that human beings already do, like writing, reading, or anything that feels natural to us are considered usable. And then, just like as we humans are aware if something are making us, harming us, by being aware of the present, past, and future, we should also provide feedback or visibility of the system that would keep the users informed within a reasonable time. So just like us human have limited time, we should also do that in our interface. User control and freedom. Users often choose system functions by mistake and will need clearly marked emergency exit to leave the unwanted state without having to go through an extended dialogue. So these are kind of unique to computers, but in essence, humans needs forgiveness as well. In case like we make mistake, we can easily course correct. So it's true for computers as well, without having to go through an extended dialogue. So you don't want to have like life-threatening mistake or irrecoverable mistakes because of the nature of this computer and internet. It's a complex adaptive, and also depends on different users. Different users have different capabilities to use this. But it's important to remember that this computer are also was being it's complex, and even the one that's created this are making a mistake to them, and it used to be $1 million product. The system should support undo and redo. consistency in standards. Users should not have to wonder whether different words, situations, or actions mean the same thing. So you need to differentiate things while not making it so different that it disrupt the normal logical order of things that humans are comfortable with. The system should follow platform conventions, error prevention, rather than just a good error message. The system should incorporate careful design that prevents a problem from occurring in the first place. Either eliminate error prone conditions or check for them and present users with a confirmation option before they commit to the action. Recognition rather than recall. Minimize the user's memory load by making objects, actions, and options visible. The users should not have to remember information from one part of the dialogue to another. Instructions for use of the system should be visible or easily retrievable whenever appropriate. Flexibility and efficiency of use. Accelerators, unseen by the novice user, may often speed up the interaction for the expert user, such that the system can cater to both inexperienced and experienced users. Allow users to tailor frequent actions. So, you should design for different level of expertise. So, an expert wants a shortcut to kind of feel like they have advanced, while the user can, like, you can hide the buttons, special buttons for experts that allow them to do more, and while at the same time designing for novice users. Kind of like in games, you are able to provide advanced commands for experts. Aesthetic and minimalist design. Dialogue should not contain information that is irrelevant or rarely need. Every extra unit of information in a dialogue competes with the relevant units of information and diminish their relative visibility. So again, it is related to salient information in which we need to be organized. Help users, or we need to clean things in order for us to make way for things that is important to us. Help users recognize, diagnose, and recover from errors. Error messages should be expressed in plain language, not codes. Precisely indicate the problem and constructively suggest a solution. Help and documentation. Even though it is better if the system can be used without documentation, it may be necessary to provide help and documentation. Any such information should be easy to search, be focused on the users. So just like in a internal tool like Salesforce, you need to get the balance in which you don't want people to get an error, but you're also prepared in case that happen using knowledge-based articles. There's a balance for that. So you got to really know your user and really see their usability problems. A slightly modified version was produced by Jacob in 2020, this time with examples, figures, and videos to help readers understand how to use the heuristics. There's even a free poster that you can download. Designers and researchers evaluate aspects of the interface against the appropriate heuristics. For example, if a new social media system is being evaluated, the designer might consider how people would add friends to their networks. This might involve modifying Nielsen heuristics or even adding new ones to ensure that adding friends gets evaluated. During each iteration, usability problems will be identified and ways of fixing them may be suggested. Some are too general for evaluating products that have come onto the market more recently, such as digital toys, ambient devices, web design, virtual reality, games, conversational agents, mobile apps, and IoT, to name just a few. Designers and researchers have therefore developed their own heuristics by tailoring Nelson heuristics with other design guidelines, market research, results from research studies, and requirement documents. So again, just remember that what we're doing right now is we're mastering the basics. So in case we get this unexpected advanced heuristics like virtual reality or conversational agents, we can apply this basic principle and then tailor it to that unique case. Now, when users know the current system status, they learn the outcome of their prior interactions and determine next steps. Predictable interaction create trust in the product as well as the brand. So these are the new heuristics. The way you should design depends very much on your specific users. Terms, concepts, icons, and images that seem perfectly clear to you and your colleagues may be unfamiliar or confusing to your users. When a design's controls follow real-world conventions and correspond to desired outcomes called natural mapping, it's easier for users to learn and remember how the interface works. This helps to build an experience that feels intuitive. So, he kind of changed the language here that instead of following design controls should follow real-world conventions, or making it as natural as possible so that it's easier for user to learn and remember how the interface works. This helps to build an experience that feels intuitive. Another add with this is that people, as we become expert, there is a disadvantage because we were far from the beginner's mindset in which we don't know anything about it. So it's kind of like built into this bias of humans. So knowing the current status is kind of like built into this natural way of how the universe works, in which people like us, we are aware if like we are in danger. So let's say you jump into the building, you are aware that you're gonna break your your life, right? So, and then when it's easy for people to back out of a process or undo an action, it fosters a sense of freedom and confidence. Exits allow users to remain in control of the system and avoid getting stuck and feeling frustrated. So it's related to learnable and then making the product usable or interacting with it, because you won't interact if you get stuck, right? That's the main thing about this, is that you don't want to get stuck so that the user continue to use it. Jacob Law states that people spend most of their time using digital products other than yours. Users' experience with those products set their expectations. Failing to maintain consistency may increase the user's cognitive load by forcing them to learn something new. There are two types of errors, slips and mistakes. Slips are unconscious errors caused by inattention. Mistakes are conscious errors based on a mismatch between the user's mental model and design. So there's two types of errors. Slip are unconscious, and it's because of our inattention or the lack of prior knowledge. But most people don't have this lot of knowledge with computers, so it's safe to assume that you should design with this in mind, with the slips error. And then mistakes, it's a conscious error based on mismatch of people mental model. Humans have limited short-term memories. Interfaces that promote recognition reduce the amount of cognitive effort required from users. Flexible processes can be carried out in different ways so that people can pick whichever method works for them. So humans have limited short-term memories. So no matter how smart we are, we have this limited memory, or we have limited energy in a day that we can use. So make sure you're optimizing not for searching but for recognizing, kind of like making everything automatic. Flexible process, it's related to how we should provide an expert commands for expert users, and while at the same time allowing newbie to work with it. These heuristics doesn't mean you have to use a flat design. It's about making sure you're keeping the content and visual design focused on the essentials. Ensure that the visual elements of the interface supports the user's primary goals. So it's kind of like the visual support the theme, kind of like going back to the main point or the main grammar or paragraph, or let's say a book of what is your business trying to achieve. The visual should match that business theme. These error messages should also be presented with visual treatments that will help users notice and recognize them. So in this case, you also need to avoid this human tendency to think outside, or like sometimes we have a tendency to not be motivated or to think of things. So you want to like provide notification systems that will put the important things on their in front of them so that they can do something about this. This error message should be also presented with visual treatments that will help, and documentation content should be easy to search and focus on the user's task. So before, we want to provide help, right, in case the users. Now help, we can't really get out of it, so there's always something error that will come up that needs a knowledge base article or help. In this case, you make it easy to search, you make it recognizable and automatic, keep it concise, and list concrete steps that need to be carried out. So provide the steps in detail, small step at a time or detailed step that will allow the users to tackle this big issue, because usually you need help if there's like some big errors or something really hard that your developer could not fix. Once I had finalized this list of violation, I gave a severity rating to each. I used this severity rating scale. So these are the severity rating scale that you could use in case you want to you find a website and then try to find a usability issue on that. You can say don't agree that this is a usability problem, cosmetic problem, minor usability problem, major usability problem, important to fix, usability catastrophe, imperative to fix. So the execution now, Expedia task purchasing a round trip flight from San Francisco, California to Istanbul, Turkey, departing on 7/11/2015 and returning to 8/11 on 8/11/2015. So these are the violations that we uncover on this website in 2015. It was difficult to find out information about bag fees. Severity 3, major usability problem. Heuristics violated, recognition, and help. Description: when I click on more info under bag fees, another tab opens and show me this information. So here, it's not clear. So people like, if analytics was discovered before and then you can track every element in the page that your user click, you can definitely see that this is a problem. But because we don't have that advanced analytics back then, or like there's like a knowledge gap, there's a like host of problems, and because you don't do your user research correctly or right, you get this usability issue, which is like what it says here, important to fix. Another concern is the number of researchers needed to carry out a heuristic evaluation. So that identifies the majority of usability problems. So for this evaluation, since you don't need users, you need an expert that knows this field. But the issue is that it's expensive for expert to be in the same project at the same time, because their time is expensive. Empirical tests were conducted suggesting that 3 to 5 researchers can typically identify up to 75% of the total usability problems, as shown in figure 16.1 in 1994. However, employing several researchers Researchers can be resource intensive. Therefore, the overall conclusion is that while more researchers might be better, fewer can be used, especially if they are experienced and knowledgeable about the product and the people for whom it is designed. So, while more researchers might be better, it may not be worthy of cost. Heuristic evaluation for websites. One of these was developed by Andy after discovering the Nielsen. So it was developed in 2007 after discovering Nielsen heuristics did not address the problems of the continuously evolving web. So the extra from Bud heuristic are shown here. Highlights issues that are fundamental for good website design. Notice that a difference between this and Nielsen's original heuristic is that Bud placed more emphasis on information content. Now, a lot of scientists tailor this Bud or Nielsen heuristic to their own case, kind of like a framework that we've discussed in the previous chapter. Clarity, make the system as clear, concise, and meaningful as possible for the intended audience. Write clear, concise copy. Only use technical language for a technical audience. Write clear and meaningful labels. Use meaningful icons. So it's like another way of saying that make it make sense. Make the interface make sense so it's easy to learn. Clear, concise, and copy. Depending on the audience, again, because some audience wants like more complex, but the basics are true. Clear, when you start with that, with clear, concise, and copy, you automatically are able to communicate with the expert because expert could understand basics, right? Minimize unnecessary complexity and cognitive load. Make the system as simple as possible for people to accomplish their task. Remove unnecessary functionality. Process steps and visual clutter. Use progressive disclosure to hide advanced features. Break down complicated processes into multiple steps. Prioritize using size, shape, color, alignment, and proximity. So again, SSC, let's create mnemonics for this. I would say CASP, CASSP. So color, alignment, size, shape, and proximity. I would say shape, alignment, and proximity was not noticed or is the things that often missing when people are considering these things. Now, for breaking down complicated process, I have a theory for this. Now, because world works in compound law, in which there is really no big things that we do, it is a combination of small things. So that's why breaking things in smaller steps are effective. Provide context. Interface should provide people with a sense of context in time and space. Provide a clear site name and purpose. Highlight the current section in the navigation. Provide a breadcrumb trail or add entries to the browser history that is show where the person has been in a website. Use appropriate feedback messages. Show the number of steps in a process. Reduce perception of latency by providing visual cues, for instance, a progress indicator, or by allowing people to complete other tasks while waiting. Promote a pleasurable and positive experience. People should be treated with respect, and the design should be aesthetically pleasing and promote a pleasurable and rewarding experience. Create a pleasurable and attractive design. Provide easily attainable goals. Provide rewards for usage and progression. For example, Lucas in 2019 carried out a survey of Polish public administration websites with the aim of identifying the common usability problems. They used Nielsen's heuristics to evaluate 60 websites, and they grouped the problems that they identified according to severity. The most serious problems were concerned with navigation. These include an intuitive menu layout with too many options, navigation between pages, and dead links. Navigation websites to find what one is looking for is a general problem, but particularly for people who need essential information from government websites. A similar approach to BUDS is also taken by Lei in her article entitled A Guide to Heuristic Website Reviews in 2011. In this article and in a more recent one by Tony Gran in 2018, techniques for making the results of heuristics evaluation more objective are proposed. This can be done either to show the occurrence of different heuristics from an evaluation or to compare the results of different researchers' evaluations. As shown in figure 16.2. First, a calculation is done to find the mean number of usability problems identified by each researcher, which is then displayed around the diagram. In this case, there were 7 researchers. So they evaluated the same product as 7 researchers. So they compared different heuristics of different researchers to produce a more triangulate or different perspectives. Then a single value representing the mean of all researchers' individual means is calculated and displayed in the center of the diagram. In addition to being able to compare the relative performance of different experts and the overall usability of the design, a version of this procedure can be used to compare the usability of different prototypes for comparisons with competitors' product. So a version could be used as well depending on the version of the product, on how researchers evaluate it, and the different prototypes for comparisons for how accurate this different evaluation of the different expert. So rather, diagram showing the mean number of problems is identified by each of the 7 researchers and the overall mean of all the researchers, which is shown in the center of the diagram. Activity: use some of BUDS heuristic to evaluate a website that you visit regularly. Do these heuristics help you to identify important usability and user experience issues? If so, how? How does being aware of the heuristics influence how you interact with a website? Was it difficult to use these heuristics? Comment: the heuristics focus on key usability criteria, such as whether the websites seem unnecessarily complex and how color is used. BUDS heuristic also encourages consideration of how people feel about the experience of interacting with a website. So it talks about how people feel and the usability criteria of complexity. Is there irrelevant information there? Being aware of the heuristics may lead to a stronger focus on the design and interaction, and it can raise awareness about what the person is trying to do and how the website is responding. When applied at a high level, these guidelines can be tricky to use. For example, what exactly does clarity mean in regard to a website? Although the detailed list, write, clear, concise copy, only use the technical language for a technical audience and so on, provide some guidance, making the evaluation task a bit easier. It may still seem quite difficult, particularly for those not used to doing heuristic evaluation. So, when you apply this in high level, you don't know what really clarity means, right? Even if you have this like heuristic that you can use to test a website, you can copy and paste it. It's not that easy to actually test it because there's a lot of vague, what do you mean by clarity, for whom clarity means are you saying, etc. but it can raise awareness to the main point of the issue. Doing heuristic evaluations. So how can we actually do this evaluation? Typically, each researcher will take at least 2 passes through the app, website, or product. The first pass gives a feel for the flow of the interaction and the product scopes. The second pass allows them to focus on specific interface elements in the context of the whole product and to identify potential usability problems. So basically, first you undergo a UX or overall experience on all the functionality of the app, website, and the product. You give it an overview or big picture, and then after that you get into the details. So the second allow you to the specific interface elements and tasks. If the evaluation is for functioning product, the researcher will typically have some specific task in mind so that their exploration is focused. So if it's already functioning product, like you're not trying to create it, then the focus should be, so it's called summative evaluation, in which the product are already done and complete. Now you will have to focus on a specific task in detail. You don't need to like undergo to this overview, since you already know this product. Suggesting tasks may be helpful, but many UX researchers suggest their own task. However, this approach is more difficult if the evaluation is done early in design, when there are only screen mock-ups or specifications. So if it's early, you only have this theory. You don't have a clue on how it actually works in the real world. So it could be hard if this UX researcher have their own task or their preconceived heuristic that they will use. A briefing session in which the researcher is briefed about the goal of the evaluation. If there is more than one researcher, a prepared script may be used to ensure that each person receives the same briefing. So first, you have the goal, and then a consent form on things that the researcher need to know before they conduct this, and make sure you have this the same for each researcher. The evaluation period, in which the researcher typically spend 1 to 2 hours independently inspecting the product using the heuristics for guidance. The debriefing session, in which the researchers come together to discuss their findings with designer and to prioritize the problems they found and give suggestions for solutions. So this is the last part, which I think most often people forgot, in which researcher actually talk about their ideas and then trying to debate or achieve triangulation. So it's another 2 hours. That's why it is time consuming. So that's how you conduct that heuristic evaluation. Now, dilemma. Shortly after heuristic evaluation was developed, several independent studies compared it with other methods, particularly user testing. They found that the different approaches often identify different problems, and that sometimes heuristic evaluation misses severe problems. In addition, its efficacy can be influenced both by the number of experts and by the nature of the problems, as mentioned earlier. Heuristic evaluation, therefore, should not be viewed as a replacement for user testing. So again, these are not the be-all and all. It's just a part, it's just a framework, a method, a way of doing things that allows us to get a more complete view. So further research is required. So it can't replace this user testing, the actual testing that we do in ethnography and in a lab. So this is a part of like indirect observation, which is the any part that we discussed in the previous video. Another issue concerns researchers reporting problems that don't exist. In other words, some of the researchers' predictions are wrong. Bill cites analysis from 3 published sources showing that about 33% of the problems reported were real usability problems, some of which were serious, while others were trivial. So the issue with this, another issue with this is that researchers report problems that don't actually exist. So some of the prediction are wrong. Based on our research, it showed that 33% of the problems reported were real, and some of which were serious, while others were trivial. The researcher missed about 21% of the problems. Again, 21%. So that's a lot of usability problems. But it may not be the major ones that will actually make your users leave or make the people leave your site. Furthermore, about 43% of the problems identified were not problems at all. They were false alarms. This means that only about half of the problems identified were true problems. In an evaluation of a smartphone app for cultural heritage, the Experience Interaction Design researchers identified more usability problems than novices, 19 to 14 respectively. The experienced researchers also identified usability problems that were more severe. So, basically, you have to balance your budget. So, as in this case, if you have like this 19 to 14, so if those 5 problems they encounter will cost you, let's say, $1 million or a lot of money, then it may be worth it to get the researcher. But if your website are not making that much, you can just do this yourself. Like you are a novice, right? You know these heuristics. You just need to identify it. The experienced researcher also identified usability problems that were more severe, evaluating for accessibility using the Web Content Accessibility Guidelines. So this is kind of like this is part of heuristics as well, the WCAG for accessibility. We've discussed this in the previous video, so we're just gonna read this. The concept of web accessibility is old as the web itself. Tim said the power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. To fulfill this mission, the WCAG were created, approved, and released in 1999. While all the various WCAG documents online would add up to hundreds of printed pages, the key concepts and core requirements are summarized in WCAG 2.1 at a glance. A document that could be considered to be a set of HCI heuristics. The key concepts of web accessibility according to WCAG are summarized as poor, perceivable, operable, understandable, and robust. Perceivable, provide text alternatives for non-text content, provide captions and other alternatives for multimedia, create content that can be presented in different ways, including by assistive technologies without losing meaning, making it easier for users to see and hear content. Operable, make all functionality available from a keyboard. Give users enough time to read and use content. Do not use content that causes seizures or physical reactions. Help users navigate and find content. Make it easy to use inputs other than keyboard. Understandable, make text readable and understandable. Make content appear and operate in predictable ways. Help users avoid and correct mistakes. Robust, maximize compatibility with current and future user tools. These guidelines can be used as heuristics to evaluate basic web page accessibility. For example, they can be converted into specific questions such as the following. Is there alt text and graphics? Is there entire page usable if a pointing device cannot be used? Is there any flashing content that will trigger seizures? Is there captioning on videos? Turning design guidelines, principles, and golden rules into heuristics. A more principled approach is for designers and researchers to translate the design guidelines into questions. Tony suggests first converting the heuristics into principles and then identifying pertinent questions to ground the principles so that they are useful. For example, consider the heuristic visibility and system state. which is a composite between Nielsen and the Tognazini heuristics. Granulars suggest the following question: does the application include a visible title page, section, or site? Does the user always know where they are located? Does the user always know what the system or application is doing? Are the links clearly defined? Can all be visualized directly? No other actions are required. So we turn this statement into questions. Even better, we turn these statements into questions, and then we tailor it to our specific use case. Does the application Other examples of developing heuristics based on guidelines or rules include shared groupware in 2022, video games in 2008, multiplayer games in 2009, online communities in 2009, information visualization in 2010, CAPTCHAs in 2015, e-commerce site in 2018, and quality assessments for mobile applications on smartphones in 2019. In the mid-1980s, Ben also proposed 8 golden rules, which are design guidelines that have been modified and are frequently used as heuristics for evaluation. So, these are another heuristics that was from since 1980. So it's like a classic heuristics as well, and it was revised. So another way of thinking other than Nielsen heuristic revised version. Strive for consistency, seek universal usability, offer informative feedback, design dialogues to yield closure, prevent errors, permit easy reversal of actions, keep users in control, reduce short-term memory load. So what's the similarities for this? Strive for consistency, universal usability, kind of like related to making things more natural, offer informative feedback, kind of like being aware on present, past, and future, design dialogues to yield disclosure, kind of like errors that makes it recognizable and easy to learn, prevent that will allow you to solve the error, prevent errors, permit easy reversal of actions, keep users in control, reduce short-term memory load. Keep users in control. I have some interesting idea or metaphor about this. Kind of like here, us on Earth, right? We have like a complete choices on what we do. Though there's some caveats with that because a lot of things become habitual, but you also want to do that level of control to users. Reduce short-term memory load because of the fact that it's limited. Comparing heuristics, which guidelines should you use? Compare Nielsen's or modified usability heuristic by Schneiderman, 8 golden rules, which are similar and which are different. Then select another set of heuristics or guidelines for evaluating a system in which you are particularly interested and add them to the comparison. A few heuristics and golden rules nearly match. For instance, NISL guidelines for consistency and standards, error prevention, and user control and freedom to match up with Schneider's rules of striving for consistency, prevent errors, and keep users in control. So consistency, prevent, and then it's hard to find heuristics and golden rules that are unique to each researcher set. Aesthetic and minimalistic design appears only in Nielsen list, where seek universal usability appears only in Schneider's list. In the end, perhaps the best way forward is for researchers to select the set of heuristics that seem most appropriate for their own evaluation context. We selected the Web Accessibility Guidelines. These guidelines specifically target the accessibility of websites for users with disabilities. The ones under Perceivable, Operable, and Robust do not appear in either of other two lists. These guidelines listed for Understandable are more like those in The guidelines listed for Understandable are more like those in Nielsen and Schneiderman's list. They focus on reminding designers to make content appear in consistent and predictable ways and to help users to avoid making mistakes. So different language, different way of explaining things, right? Different frameworks and different contexts. Walkthroughs. Walkthroughs offer an alternative approach to heuristic evaluation for predicting users' problem without doing user testing. As the name suggests, walkthroughs involve walking through a task with a product and noting problematic usability features. While most walkthroughs methods do not involve users, others such as pluralistic walkthroughs involve a team that may include users as participants as well as developers and usability specialists. It's a nuanced way of doing this indirect observation because sometimes it requires the users, the developers, and you or the UX expert. In other words, how difficult it is to start using the system without reading the documentation. Cognitive walkthroughs. A cognitive walkthrough, which is the first part of walkthroughs, as the name implies, takes a cognitive perspective in which the focus is on evaluating designs for ease of learning. A focus that is motivated by observations that people learn by exploration. So this came from the principle that or observation that people learn by exploration. This well-established method in 1994 is often integrated with a range of other evaluation and design processes. A key feature of cognitive walkthroughs is that they focus on evaluating designs for ease of learning. So in 2022, it was described that these are often used with other type of evaluation. So here are this principle. The characteristics of typical users are identified and documented, and sample tasks are developed that focus on the aspects of the design to be evaluated. A description, mock-up, or prototype of the app or system to be developed is also produced, along with a clear sequence of actions needed for people to complete the task. So a prototype needs to be produced. Either it's a paper prototype or a physical prototype. Now, the difference with heuristics. The heuristic, you can think of this high level or big picture, while this is like a task level or detailed level. A designer and one or more UX researchers come together to do the analysis. So it's the same with heuristics. That designer come together or needed. The UX researchers walk through the action sequences for each task, placing it within the context of a typical scenario. As they do this, they try to answer the following questions. Will the correct action be sufficiently evident to the user? Will they know what to do to achieve the task? Will the user notice that the correct action is available? Can they see the button or menu item that they should use for the next action? Is it apparent when it is needed? So another way of looking at it is that instead of a statement, which normal in heuristics, you're asking questions, which often questions are more specific or detailed. Will the user associate and interpret the response from the action correctly? Will they know from the feedback that they have made a correct or incorrect choice of action? In other words, will users know what to do, see how to do it, and understand from the feedback whether the action was completed correctly or not? So here, you can think of this as a recognition part of the heuristic. Recognition as well, sufficiently available. Ability to undo the error. As the walkthrough is being done, record of critical information is compiled. The assumptions about what would cause problems and why are identified. Notes about side issues and design changes are made. A summary of the result is compiled. The design is then revised to fix the problem presented before making the fixes. Insights derived from the walkthroughs are often checked by the testing them with real users. In a way, you're kind of like describing an entire set of experiment or test, right? Because you also analyze this, you take note, you record it, and then you focus or prioritize information you're trying to get, and then you learn from it. So it's kind of like a way of describing an entire session, When doing a cognitive walkthrough, it is important to document the process, keeping account of what works and what doesn't. So let's back up here. So again, a walkthrough, kind of like describing an entire session. And then when doing a cognitive walkthrough, it's important to document the process, keeping account of what works and what doesn't. A standardized feedback form can be used in which answers are recorded to each question. Any negative answers are carefully documented on a separate form along with details of the product, its version number, and the date of the evaluation. So version, negative, so that's kind of like the principles, the same with heuristics, right? You're trying to get the negative part so that when you are encounter that, or the user encounter that, you can maybe alleviate that anxiety from them, or like resolve that worst part, kind of like worst and then base, preparing for worst and best case, and then the middle phase in which you are prepared for all scenarios. So these are one of the principles: the version, the date, the negative part are all in one principles, right? You're trying to prepare for the worst or something like that. It's also useful to document the severity of the problems. For example, this includes how likely a problem is to occur and how serious it will be for users. The form can also be used to record the process details outlined in steps 1 to 4, which is here the characteristics of the user, a designer, the UX researchers, walk through the action sequence for each task, placing it within the context. As the walkthrough is being done, a record of critical. So for these notes, you can put all of those things in one note, kind of like an entire thing, or a way of like describing this whole session, including the things that could be done or could not be done, because you can entirely avoid doing or compiling this step 1 to 4 in this one big note. Kind of like, in a way, you're trying to get to do a design language, which was discussed in the previous videos, in which you're describing an entire session or entire phenomena that could cover a lot of cases. In this case, we can choose to not make a note, or we can choose to make a note of this 1 to 4 in that. But either way, we describe this as cognitive walkthrough. Now, here, cognitive walkthroughs have been adapted to evaluate other products such as smartphones in 2013, large public displays in 2017, and a system to manufacture electric scooters in 2015. The method of doing cognitive walkthroughs has also been adapted for different circumstances. Identify the goal you want to examine, identify the task you must complete to accomplish that goal, document the experience while completing the task. So if you want to like boil it down into 3 steps, here it is. Cognitive walkthroughs are sometimes confused with heuristic evaluations, but while both methods uncover usability problems and take the user's point of view, heuristics evaluation typically focus on the product as a whole, not specific task. Documenting the experience. Since experience is subjective, it's important to structure how an evaluator document it so that all walkthrough use the same criteria. So another thing that it noticed or it described is that people are different and the observation is subjective. So it's also important to put a criteria or a structure in this chaotic or subjective observation of people. Traditionally, the evaluator asks or answers 4 questions during each task. Will the user understand how to start the task? Are the controls conspicuous? Will the users know the control is the correct one? Was there feedback to indicate you completed or did not complete the task? Were you able to complete the task? During the cognitive walkthroughs of the check-in procedure for this app, the evaluator this is not an app. Yeah, you can think of that an app, but it's an interface at the hospital. It's not like an app in phone. The evaluators start by looking at the first screen that the new patient would encounter to check in. The correct action for the patient would be to tap on the square in the bottom right corner if a new patient. The evaluator then addressed the four analysis questions that have been adopted from the original list by Wharton in 1994. So where is Wharton? Here is Wharton, the steps which was here. So let's back up. Here, question, will the user try to achieve the right result? Yes, patients will be directed by a receptionist upon entry to check in for their appointment. And the application includes the phrase patient check in the header. Note, group discusses that there may be instances where the receptionist is away from the desk. Although the phrase patient check in is shown in the app, its placement in the top right corner could be perceived as branding, causing it to be overlooked. They agreed to further look for design solution for this situation. So here it is. Will users notice the correct action is available? Yes, all actions buttons are positioned within the body of the page using a highly salient visual styling that effectively communicates tappability. Will users associate the correct action with the result they're trying to achieve? No, the group discusses the selecting from the four options provided on the screen requires a lot of cognitive effort for new patients because they must assess and eliminate the incorrect options before determining the correct one. New patient. So if you're a new patient, you might be confused what would you click here. So sometimes it's better to choose if you're a new patient and the old patient right before, because the new patient does not necessarily have an access to access code, right, or patient search since you're a new patient. So the only way for you to one of the solution that could be done is a new patient and old patient. So once you click the old patient, that's the only time you will show this available function. So here, the group agrees to further seek ways to simplify the design by first asking whether the patient is a new or existing patient and then providing returning visitors various record lookup options. After the action is performed, will users see the progress made toward the goal? Yes, the page changes in a form with the heading. Enter your personal information is displayed. Establish roles and rules. Cognitive walkthroughs, like most well-run workshops, rely on clear rules and assignment of participant roles. It's possible to wait until the beginning of the evaluation session to discuss roles and rules, but doing so in advance of the meeting can maximize the time for evaluation. Key roles: facilitator. The facilitator is typically the organizer of the session. This person is responsible for making sure that participants are prepared for the session and ensures that the discussion is in line with the purpose and rules of the meeting, so the session runs as smoothly as possible. Presenter. The presenter job is to make the prototype viewable to the entire group and serve as proxy for the users. Interacting with the interface as the group determines the users would. The facilitators may double as the presenter if necessary. So the presenter may not necessarily speak, but they are the one that will present this prototype viewable to the entire group, and they will serve as proxy for the user. Interacting with the interface as the group determines the user would. The recorder captures the output of the cognitive walkthroughs, discussion, and the determination made by the larger group. This person will also summarize the findings of the groups after the session is finished. Evaluators. Most meeting participants serves as evaluators. The facilitator, presenter, and recorder can also serve as evaluators. Evaluators follows along with the presenter or facilitator and assess the interface by responding to the prompts defined by the cognitive walkthrough methodology, which is discussed later. Sorry, we've discussed that already. So most meeting with is basically we're trying to evaluate in this session. So the facilitator, presenter, or recorder can act as this, but it's important to be clear on who is facilitator, presenter, recorder, and evaluator. So evaluator, they follow along with the presenter, and then facilitator, and then assess the interface by responding to the prompts defined by the cognitive walkthrough methodology. So it's kind of like the user UX design. It could be the user. For participatory cognitive walkthrough, it can also be the developer. But for cognitive walkthrough, it's usually the UX designer. And then before that, and then while they're doing that, here is the recording interface they use. It's great. It's actually a great interface. It allows you to, there's already a question. The evaluators just need to answer it. Like these days, the system uses red error text to communicate that there's a potential duplicate expense. She will know she must evaluate and resolve the duplicate, so the expense is only recorded once. So check, will the user to try to achieve the right result? So it shows the user, or if she's choosing the wrong thing. A standard blue link reading merge expenses is offered on close proximity directly following the error text. So they would see a call to action. So will the user notice that the correct action is available? Yes. Will the user associate the correct action with the effect they're trying to achieve? Yes. The label merge expenses is straightforward resolution for resolving duplicating by combining the two into one record. After the action is performed, will the user see that progress is being made toward the goal? Yes. There's a correction between the system response and user goal. One of the record is removed and the error icon disappears from the remaining record. Perfect. So here, after the group has finished evaluating each step for the defined task, the workshop concludes. The recorder should package up the completed templates for each task into a shareable format. So after they evaluate it and for the defined task, it is done. So the recorder should package the completed templates for each task into a shareable format. The session facilitator should then summarize the overall findings of the session and track the identified areas for improvement in the project management tool used to track work. So these are the last steps: summarizing and learning. Okay, SL, guys, remember here, action, and then the result. Select the play icon on one of the expense in error, fail. Select the merge expense link, success. Approve the merge in the confirmation model, success. To cope with these problems, Rick adopted the method by asking fewer detailed questions and curtailing discussions. This meant that the analysis was more coarse-grained but could normally be completed in about 2.5 hours. He also identified a leader and set strong ground rules for the session, including a ban on defending design, debating cognitive theory, or doing designs on the fly. So, to make this session of cognitive walkthrough faster, Rick invented a new method in which he created the rules such as no no to defending a design, debating cognitive theory, or doing designs on the fly. And then he made the question in the fewer, detailed, and curtailed question. Their method involved an informal, simplified, streamlined cognitive walkthrough followed by an informal, pluralistic walkthrough, which we will discuss next. So pluralistic, it involves other participants, like it could involve users. So these are the unique case. When compared to a traditional user study on the same user interface, they found that approximately 80% of the findings from the user study were also revealed by SCW, or this cognitive walkthrough, streamlined cognitive walkthrough. So you don't need sometimes to spend big money on actual usability testing if you just want an 80% accuracy. Again, it really depends on the budget. Pluralistic walkthroughs. In a pluralistic walkthroughs, each person is asked to assume the role of a typical user. Scenarios of use consisting of a few prototype screens are given to each person, who writes down the sequence of actions that they would take to move from one screen to another without conferring with each others. So scenarios of use are given consisting of a prototypes, whether it's low or high fidelity, given to each person who write down the sequence. So the difference of this, it's still the same, it write down the sequence, but you can have host of different participants other than the UX expert. Then they all discuss the actions they each suggested before moving on to the next round of screens. So here, the another difference with the cognitive walkthrough is that before moving to the next, they actually talk about or discuss what they found. This process continues until all of the scenarios have been evaluated. So this was created since 1994. Pluralistic walkthroughs focus strongly on the detailed steps involved in completing a task, which can be beneficial for designing a safety critical systems where usability problem identified for a single step could be critical to its safety or efficiency. This approach lends itself well to participatory design practices as discussed in Chapter 12, Designing Prototype and Construction, by involving a multidisciplinary team in which users play a key role. Time constraints may also result in using a limited number of scenarios, and hence only a few paths through the system can usually explored. So another difference is that it is limited to a few scenarios, but there is similarity for this in participatory design, in which triangulation are essential, in which you're trying to get different opinions of different stakeholders. The users will receive a set of hard copies of the dialogues that they need to perform the given task. Kind of like this one before. Documentation or help functions are usually not required because the interface designers are around to answer any questions or clear any doubts. The methods will include three types of participants in the same walkthrough session, namely the representative users, system designers, and usability experts. So documentation are not needed because the usability experts are there. Analytics and A/B testing. So another type of indirect observation. People action can be automatically recorded by software, including presses, mouse or other pointing device movements, sound, video, time spent searching a web page, looking at help systems, and task flow through software modules. An advantage is that large volumes of data can be logged automatically and then explored and analyzed using visualization and other tools. Though the downside of this can be that evaluators may feel overwhelmed and lost in their data. So advantage is that a lot of data could automatically be logged without setting up that expensive UX or cognitive walkthrough, especially usability testing. So because you're recording it remotely using this software, web analytics, and then the downside is that you really need to know how to analyze this big data, how to find critical incident analysis, how to use the software, right? How to being aware of the cognitive. So a lot of skills are needed if you want to do this. Web analytics. A web analytics is a form of interaction logging that was specifically created to analyze people's activity on websites so that designers could modify their designs to attract and retain customers. For example, if a website promises information about how to plant a wildflower garden but the homepage is unattractive and it only shows gardens in arid and tropical regions, then people from more temperate zones will not look any further because the information they see isn't relevant to them. So another way of looking at this is that it is also solving customers' problem because you're trying to make your business grow. They can see how many people came to the site, how many stayed, and for how long, and which pages they visited. They can also find out about where the people came from and much more. Web analytics is therefore a powerful evaluation tool for web designers that can be used on its own or in conjunction with other types of evaluations, particularly user testing. Learning analytics play a strong role in evaluating learners' activities in massive open online courses and with open education resources. So learning analytics, basically it's all they just changed the name like learning analytics for learning websites or for learner purposes, but it's the same. The designer of these systems are interested in questions as at what point do learners tend to drop out and why. Learning that involves social interaction can be evaluated using social learning analytics. So it was just in 2014, 2019, 2021, 2022. This is generally involves the collection and measurement of students' digital artifacts and online interactions in formal and informal settings in order to analyze their activities, social behavior, and knowledge creation. Other types of specialist analytics have also been developed that can be used in evaluation studies, such as visual analytics, in which thousands and often millions of data points are displayed and can be manipulated visually, as in the social network analysis we've discussed in the previous chapter, and the visual dashboard or the different dashboard for data at scale chapter. Using web analytics, marketing and advertising companies rely strongly on web analytics to understand how their websites and those of their competitors are performing. In addition to Google Analytics, other tools continue to emerge that provide additional layers of information, good access control options, and raw and real-time data collections. So this is useful because it's being used in sales, because as you know, we are run using business, and business are run by sales. So the most common most useful tool for this are Google Analytics, but other that provides more functions such as additional layers of information, good access control, and raw and real-time data collection also exist. Crazy Egg track visitor clicks based on where they are specifically clicking, and it creates heat maps useful for web design, usability, and conversion. So like what I've said before, if that 2015, if that has this technology that allows them to track where it clicks, then it's useful in sales, right? Because Yeah, the reason we're learning this is to be useful. And what is useful? It's sales. Content Square records website visitor actions and uses meta statistics to create visual heat map reports on customer mouse movement, scrolling, and other visitor behaviors. So these are the most useful things that you could look: the customer mouse movement, scrolling, and the clicks. You can do actually measure that using Content Square. And also it also visualize it, which is amazing. It also focus on mobile apps. Contentsquare.com/clicktail. Google Analytics. Google launched Google Analytics in November 2005 and even as early as 2012. Google Analytics was the most widely used on-site web analytics and statistics service. More than 50% of the 10,000 most popular websites at the time in 2012 used Google Analytics, and its popularity continues to soar. The first segment shows information about who accessed the site, how long they stayed. The second segment shows the devices used to view the website and the pages visited. And the third segment shows the language spoken by users. And then this contains a case study about using Google Analytics for evaluating community website for error monitoring. So again, for indirect observation using analytics, here are the important metrics. Who accessed the website? How long? Shows device used to view the website, and the pages. What part of the website? Because you have multiple pages. What language spoken by the user? So here, you can also see the bounce rate, in which it means how, when they click, how often they go back immediately. So it kind of like an accidental click. So comment based on this result. 2988 users visited the site over this period, of which 2,767 were new users, possibly taking HCI and ID classes for the first time. Notice that some users must have had more than one sessions because the number of users is not the same as the number of sessions, which was 3988. So the number of sessions are 3988, which means that some users had more than one session on this, so they may click it in the multiple tabs. The number of pages viewed per session on average is 2.23. This suggests that a user probably won't have played any of the videos on the site, nor read any of the case studies in any great detail. From figure, it appears that they did check out some of the chapters, resources, and slides. The bounce rate is 66.17%. This is a useful metric because it represents a simple but significant characteristics of user behavior, which is that after visiting one page, they did not go anywhere else on the site. Typical bounce rates are 40 to 60%, while greater than 65% is high, and less than 35% is low. If the bounce rate is high, it merits further investigation to see whether there is a problem with the website. 75.5% of users access the site using a desktop, 22.3% use a mobile device, and 2.2% use a tablet. Compared to the previous week, the number of mobile users decreased by 30%. American English speakers were the largest group, 379 or 54.13%, followed by British English speakers, 89 or 12.71%, and then Chinese speakers, 69 or 90.86%. The bounce rate for the Chinese visitors were the highest of these three at 79.75%, compared with 68.67% for Americans and 71.17% for the British visitors. Yen and her colleagues in 2017 and 2020 developed a website that integrates animated smoke image, just data from sensors, and crowdsourced smell reports and wind data. Having enabled the community to monitor its own air quality and to collect reliable data to advocate for change. These researchers researchers were eager to track users' activity on their website. They carry out Google Analytics evaluation of the website from August 2015 to July 2016, which showed that there were 542 unique users who visited the website on 1480 occasions for an average of 3 minutes each. So, this indirect, seemingly just that, a useful tool, can actually change the society. So, these are example project that was example of how it can be used for the good of the society or this technology. A/B testing, another way to evaluate a website part. So let's back up. How is this able to do that? So they develop a website that integrates smoke images, data from sensors, and crowdsourced mail reports and wind data. So having enabled the community to monitor its own air quality and to collect reliable data to advocate for change. So the community were motivated to record their data using images, data from their sensors, and small reports that they were given. So they track it, and then it is used for the change in that community. A/B testing, another way to evaluate a website, part of a website, an application, or an app running on a mobile device, is by carrying out a large-scale experiment to evaluate how two groups of users perform using two different designs, one of which acts as the control and the other as the experimental condition. That is the new design being tested. This is basically a controlled experiment, but one that often involves hundreds or thousands of participants. So A/B testing, one of the difference with an actual lab experiment is that it requires thousands instead of just 5 or 30. So you can do this online only, right, to scale it. Another difference is that it is an indirect. It doesn't need the user cooperation. And then what's the same or similar is that you basically have dependent and independent variable to which you are testing your design. Like the experimental design in chapter 15 or in the previous video, from controlled to natural settings, A/B testing involves between participants experimental design in which two similar groups of participants are randomly selected from a single large participant population. For instance, from participants of social media sites such as Twitter, Facebook, Instagram, or Telegram. The main difference between A/B testing and the experiment discussed in chapter 15 is one of scale, and that typically A/B testing is done online. Another difference is that users don't necessarily know they are in an experiment nor which version they are looking at. This could be an ethical dilemma, except that typically none of the users are identified. To do A/B testing, a variable of interest is identified, such as the design of an advertisement. Group A is served design A, the existing design, and Group B is served design B, the new design. A dependent measure is then identified, such as how many times participants in each group A and B click the advertisement that they are presented with over a particular period of time, such as a day, week, or a month. So they measure. There's also a recorder here, such as in cognitive walkthrough. The difference is that the similarities. They identify a task, and then in a specified time. Another difference with cognitive walkthrough is that you can prolong the time instead of just 2 hours over a period of time, such as day, week, or month. As Ron and his colleague mentioned, A/B testing provides a valuable data-driven approach for evaluating the impact of a small or large differences in design of web and social media sites. For front-end user interface changes to back-end algorithms, from search engines such as Google, Bing, and Yahoo, to retailers, for example, Amazon, eBay, and Etsy, to social networking services such as Facebook, LinkedIn, Telegram, and Twitter, to travel services, for instance, Expedia, Airbnb, Booking.com, to many startups. Online controlled experiments are now utilized to make data-driven decisions at a wider range of companies. So, here is how you make small difference that produce big result, such as changing the title that will could earn $100 million, which we will discuss later. To get the most benefits from running an online A/B test, Kohavi in 2015 recommend first running an AA test. This is a test in which both populations of participants see the same design and should have the same experience. The result of the AA test are then examined and they should show no statistically significant difference. Following this procedure ensures that algorithm used for splitting the population is working as expected. And that the condition under which the experiment is running are indeed similar. So, if you follow this procedure, an algorithm that used for splitting the population should work as intended, and the condition are similar. So, if you're gonna use an algorithm to divide the population, make sure that the condition is similar, or you did this AA test. So, the reason why you're gonna use algorithms is because of this example, in which these are moved to this to up, and then it became this, and it let them earn $100 million. So here this is important because the internet is complex and the people's interactions can be influenced in ways that researchers do not expect. For example, by bots or the way browser refresh or redirect, which could reduce the value of the A/B test, possibly even invalidating it. There's another example for Microsoft in which they provide the price to buy the Microsoft product for $79.99. So the registration dropped in by 50%. So that is because they included the price. So instead of doing that, allowing the free option. Here I'm using a free option. So before, actually, it has been the page of Microsoft in which the free option, but they tried to do an A/B testing. They tried to include the price, and then the registration went down by 50%. So here, online controlled experiments lessons for 12 years. I recommend you watching that. So let's listen for just a little bit because it's a 1 hour video. Obviously, we're not gonna be able to listen to that, right?
I'm going to talk about online controlled experiments. I've been doing this for a while. If you want the slides, they're available at this URL, and you can go to Twitter and also find some comments and other links to things. So yeah, I think I was about to say it's been 10 years, and obviously there's enough said about that, but I was just looking at my talk from 10 years ago and noticed that one of the things I said is, conduct many controlled experiments, and I'm going to try and do that, and I've essentially done that, focused on that for the last decade or so. So this is an opportunity to share with you some of the learnings from this last decade of having run a lot of controlled experiments. So the talk's going to be split into 4 parts. I'm going to make sure everybody understands what a controlled experiment is. Pretty simple. I think this audience is probably going to get this pretty quickly, knows about it. I'll just make sure we get the terminology right. Then I'll show you real examples. These are fun examples because they're all real ones that were debated when they were out there and we were trying to understand whether they want A or B. So I'll give you an opportunity to guess which one is going to do better. We'll do sort of a vote thing. It's kind of a fun thing when the audience is reasonably large, the statistics start to work out, and I'll share with you how this works. I'll talk about lessons and pitfalls. I think this is one of the key things that I want to share with you, some of the things that we learned over time, some of the things that are important if you plan to run controlled experiments. And then I'll end with something that I consider to be sort of the cultural evolution. I spent just over 10 years at Microsoft, and I can see how groups that try to go to be more data-driven find it hard. And so there's sort of a cool analogy that we set up, the stages that you go through as you try to be data-driven. Okay, so let's get to the motivation part. Motivation is really simple. It's you want to develop a product. If you look at books from the 1990s, it was classical software development. Microsoft was writing a lot of books that basically said, some PM writes the spec, the dev tests it, the developer tests it, you got a tester out there, and then you release the software, and then you start another 3-year cycle. Okay. This worked for a while, but it got really, really long. As I said, Office releases used to be about 3 years long. And what's surprising is, the more baggage you have from prior releases, the more tests that you need to do. So at one point at Microsoft, the ratio of developers to testers was 1 to 1. Okay, that's no longer the case, but this is sort of the peak of where we got. So what we do today is more modern development. I think most of you are familiar with some of these. I'll just mention them. I view sort of Steve Blank in his book about trying to be, the 4 steps to epiphany, about trying to be more customer driven. That's one of the earliest books that started this, and then of course Eric Ries with Lean Startup caught on. A lot of things happened around the idea of building what's called an MVP, a minimum viable product or a minimum viable feature that you build and test. And so you get something out there as a minimum viable thing, you want to test it. The best way to test it is through a controlled experiment, something like an A/B test. And then based on the results, you decide whether you want to iterate or whether you just want to give up on the idea and pivot to something else. Okay? So very clean motivation. And really the motivation for me and the belief of why this is such a superior method comes from realizing that we are really, really poor at assessing the value of ideas. This is one of the key lessons that I want to share with you today through the examples, through other things that we learn about how bad we are, how humbling it is when you get to evaluate your own idea in an objective fashion. And an A/B test is probably as objective as you can. If your customers don't like it, your idea is probably not as good as you thought. And then the final point is why I love to do controlled experiments. I started off in doing sort of more classical data mining. I worked at Silicon Graphics, we had a product, and we found all this cool stuff that was usually ignored. The nice thing about controlled experiment is that you're in the critical loop. You're in this loop where things want to go out to the customers, product development, and you're in there trying to inform the decisions that make the product better. So I like this world of doing controlled experiments. I think this is one of the best areas for us to apply a lot of technologies from data mining into product development. Okay, so what's an A/B test or an A/B-N test? The concept is really trivial. You got users, they're coming in, we split them into 2 groups. Now I noted this is 50-50. A lot of people, I remember there's an eBay talk that I gave a while back and somebody says, you really don't mean 50-50, right? No, I mean 50-50 or close to 50-50. And that's because for high statistical power, you want to run the experiment with a lot of users so that you can get results pretty quickly. Now you can run this at a lower percentage, you'll have to run the experiment longer. There's a bunch of things that work against you like cookie sharing or other problems. So if you can run experiments at large percentages, that is recommended. I'll talk later on in some slides. You don't want to start this way, maybe you want to check that in a small percentage that things are okay, but then you ramp up to relatively high percentages, 10, 20, 30, 40, 50%. There's a control, which is typically the existing system. There's the treatment, which is the new idea, new feature that you want to test. And then you want to instrument as many things as possible. Like over time, we have evolved the number of the instrumentation that we have at Bing, which is where I spent a lot of my time, to collect more and more stuff. So we used to just collect a few things, and then you start collecting timies on the servers, and whether people scroll on the client, and whether they hover. Everything that the user does, if you can properly collect, might give you interesting information about whether your new feature is doing well or not well and on which axes. And then you analyze, right? You summarize everything you collected into key metrics. How many? In general, our theme is the more the better. It's an economic question of, do you really want to have thousands or do you want to have hundreds? I would encourage you to go to the hundreds. At Bing, for example, or what we call a scorecard typically has over 1,000 metrics that we look at. And if you want, there's an option to generate a big scorecard which has something like 4,000 metrics. There's a lot of stuff so that you can understand what happened and why. This helps a lot. Okay, so a few things. First of all, real users, right? We're not talking about some professor looking at 21 students that are weird. There's a cool acronym. We're talking about real users. These are your real users. In fact, I remember when I came to Microsoft, some of the VPs were horrified. You mean you're going to test against real users? Yes, this is the point. These are real users. They are the universe of people that we're trying to improve.
Does this exclude Republicans?
Okay, lawyers exclude them. Okay, so an A/B test is really the simplest control experiment. You can go out there and look at designs of experiments. There are many, many ways to do more sophisticated versions. We tend to do what are called ABNs, right? So whereas in the picture I showed you one control and one treatment, we tend to do ABNs where there's multiple treatments. Okay? Usually a small number, 2, 3, 4 treatments. You don't get into very, very large numbers. And there's also something called MVP, multivariate or multivariable designs. They're cool. A lot of statistics books mention them. We do them relatively rarely. And why is that? We find that the effort to get MVP running correctly is usually higher, and the value that you get from interactions is lower than people expect. And again, this is sort of an advanced topic that I will push. Not to this talk, if you want to stay afterwards and talk to me about that. We've written some about this, but we find ourselves mostly running what are called univariate examples, univariate tests, A, B, C, D, E. Okay, and then, of course, when the instrumentation comes at the bottom here, because you've sent users through 2 different paths, the numbers, especially real value numbers, will be different. Right? You count revenues, you count clicks, the averages will turn out to be real numbers, and it will be different between the control and treatment. So you can't just say they're different. You want to conduct statistical tests to see if they're statistically significantly different. Yeah. And what's the purpose of this mechanism? The purpose is basically to show causality. And what I mean by causality is, if the metrics are statistically significantly different coming out the bottom, you can claim that the change that you've introduced in the treatment caused the metrics to change with high probability. Okay? So this is sort of the general theme. Everybody clear? I want, if there's questions at this point, especially clarification, not politics, not open-ended questions, I'll be glad to answer them. Okay? Yeah?
Very close the loop that in particular make an automatic QA/AB test, the test goes on determines one side, change the variable, automatically roll.
Absolutely.
In that case, how many different tiers change?
So I'll just say there's a whole literature of something called multi-arm bandits, where you're running multiple examples in parallel, and you start to kill some of them off as they become clearly not the best, right? And then you take their traffic and give it to the other that are competing, so that you can determine smaller and smaller differences that are statistically significant. And so there's statistics behind this. It's something that we do. I can't say we do it a lot. The main, I'll say one thing that I believe to be true, which is that most of the best innovations that we have come from people coming up with dramatically different ideas, not from tweaking. So you can run the color test and say, which font color should I pick? And we've done those, and I have to say that sometimes they surprise me at how well they've done. There's an example that I show in one of my talks where we have like a shades of black and blue that we changed the search page, and it was worth over $10 million to change per year to change the color. And we tested, 30 colors, but they're not going to get you that 10% winner that happened once in a while. That's your question. Yep. So great question. Do we do something called OFAT, one factor at a time, or do we change multiple things? We do both. Normally, if you want to try and develop some theory about what's happening and improve your sort of knowledge about what's happening, we recommend OFAT, one factor at a time. Okay, so the problem with changing multiple things is that there's two problems. One is, first of all, you're going to lose most of the time. I'll just throw it out there. When you make a lot of changes, and I'll show you the statistics, they're usually not as good as you think, and a lot of our big experiments that do something far, we call it to jump far into space, they tend to lose. Okay, so that's one problem. The second problem is, even if you win, you don't know what to attribute the win to, right? You change 10 things, 3 of them may be good, 7 of them may be, or 5 of them may be neutral, and then 2 may be bad, but you don't know what. So when we do make a large jump into space, and we do get a positive result, we will start to decompose it. Okay, and say, let's move back in from that point, or move forward, you can do it backwards or go forward, to see which of the changes that I've made are really beneficial.
Can you paint a little bit of your impact horizon? Like, for example, commodity strength, it looks like you got very short horizon, but some changes can impact you.
Right. Yep. So I'll give you two things. One is, we run the experiments for 1 to 2 weeks. Oh, thank you. Repeat the question. So the question is the time horizon that you look at. Okay, and what is the impact of that? We typically run experiments for 1 to 2 weeks.
Not the time horizon, the impact horizon. The impact.
Whether the impact diminishes over time?
For example, if you make something that impacts the energy, that's the way
Yeah, so how do we measure the long-term impact? So one of the things that we do is when we run an experiment, we will typically reverse it and run the reverse for another period. So let's say you tested something and it looks good. You're not going to ship it to 90% of the users and keep 10% on the old version. So that we can see if the value maintains over time. I think that's what you're asking?
I think my question is going to enterprise.
Correct. So when you say enterprise, you're still building features in a B2B setting. Okay, let's push this offline. I'm not sure I'm grasping what you're asking, so stay on afterward. Yeah. How big is the sample size? I'll talk about that in another slide. Let me defer that. Yeah.
So going back to the question, we do make a change with multiple things and you find a winner. Now if you decompose, we'll start with this where we would make more sense to write that out and figure it out.
It might. The theory behind MVT is that there are interactions. Most of the time we find that the value is not as big as the books imply, right? In the sense that if you were to do hill climbing one factor at a time, you usually get to the best spot. Okay?
So there, we learned from Ron that they do not ship that for all users, but they ship it in with real users. Another key that we've got is it's controlled. Basically, you cannot test multiple variables because it will be hard to attribute it to get the cause and effect, because again it's same principle with the lab experiments. We need to be testing few at a time. Okay, so there are many tools for evaluating websites using analytics. These tools are typically fairly straightforward to use, and with just a little knowledge, designers can embed pre-written code into their design to obtain analytics. Alternatively, there are many consultancy companies that can be hired to perform this service. In contrast, knowledge of experimental design and statistics is needed to do A/B testing. So you need to have this knowledge, or what we've discussed in the previous video, statistics and experimental design, to test only a few dependent and independent variables. Now you can do this yourself because there's a lot of website or API that you can just import in your app if you know how to create an app. But there's also a third-party company that you could hire to do this for you. It's important, even if you hire like a third-party company, you need to know if they are to know how to do this to avoid getting scammed. Kind of like learning how to do your household task or any issue at your house, such as electrical, or at least a basic knowledge for that will avoid costing or avoid you getting scammed by a high price for these consultants. Predictive model. So predictive modeling provides estimates of the efficiency of different systems for various kinds of tasks. For example, a smartphone designer may choose to use a predictive model because it enables them to determine accurately which is the optimal sequence of keys for performing a particular operation. So a smartphone designer actually used this model to know what's the optimal sequence. So even the sequence of the keys that you're using to perform are being measured using this predictive models. Kind of like measuring how efficient is the algorithm. Fitloss in 1954, which predicts the time it takes to reach a target using a pointing device, was originally used in human factors research to model relationship between speed and accuracy when moving toward a target on a display. In interaction design, it has been used to model the time it takes to point at a target, for example, on an icon or screen, based on the size of the object and the distance to the object, based on McKinsey in 1992 and revised in 2018. Here, Fitloss state T equal K log square log D divided by S plus 1.0. Where the T time to move the pointer to a target, D distance between the pointer and the target, S equal the size of the target, K equal a constant of approximately 200 milliseconds per bit. In a nutshell, the bigger the target, the easier and quicker it is to reach it. This is why interfaces that have big buttons are easier to use than interfaces that present lots of tiny buttons crammed together. Fitloss also predicts that the targets accessed most quickly on any computer display are positioned at the four corners of the screen. This is because of their pinning action. In other words, the side of the display constrains the user from overstepping the target, though this may not be true for all kinds of interaction devices. This is especially useful for mobile devices where there is limited space for placing icons and buttons. So basically the icons displayed in four corners or anything displayed there are easy to select because there's a constraint, so you won't go over it. That's why this menu tab of start and then this back are there, and then this X and then this, so that you know that you won't make a mistake. So this is especially useful for mobile devices where there's a limited space for placing icons and buttons. Fitts law has been useful for considering the effectiveness of new forms of input, such as different game controllers, cursor positions for 3D selections in VR, and gaze input on large displays with touch and mouse input, as well as assessing the effects of finger with for pointing and touch device. So it was invented in 1954 and still being used today in the new technologies such as this mobile phones and then game controllers. So let's watch.
Fitts law is a formula for calculating how long it will take a user to acquire a target, meaning navigate to a precise location like a link or a button on a screen. The amount of time this takes depends on two factors: how far away the target is and how big it is. The distance part of the equation is pretty obvious. After all, things that are further away usually take longer to reach. But the size of the target also makes a big difference. Tiny buttons take longer for people to click because users must move much more carefully to reach the exact right position. And being that careful requires more time and attention. So what does this mean for you as a designer? Well, number one, your most important links and buttons should be nice and big so that they're fast and easy to click. Number two, for secondary targets, look for reasonable ways to make the click zone larger. such as adding labels next to clickable icons. Or if you have a label and an image, make the image clickable as well as the label. Number 3, whenever you can, put your targets in a place where people may already have their mouse. For example, edit controls for a row of data should be right next to the row they edit, not all the way on the far edge of the screen. The point of understanding Fitts law is not to use it to calculate the exact number of seconds it will take people to click every link. But understanding the principles involved enables you to make your most important links easier for people to use.
There you go. So let's
And an image, make the image clickable as well as the label. Number 3, whenever you can, put your targets in a place where people, because users must move much more carefully to reach the exact right position. And being that careful requires more time and attention. So what does this mean for you as a designer? Well, number 1, your most important links and buttons should be nice and big so that they're fast and easy to click. Number 2, for secondary targets, look for reasonable ways to make the click zone larger, such as adding labels next to clickable icons. Or if you have a label and an image, make the image clickable as well as the label. Number 3, whenever you can, put your targets in a place where people may already have their mouse. For example, edit controls for a row of data should be right next to the row they edit, not all the way on the far edge of the screen. The point of understanding Fitts law is not to use it to calculate the exact number of seconds it will take people to click every link. But understanding the principles involved enables you to make your most important links.
So the most important links or buttons shall be big and near the it's easy to click. You know, the farther the icon or button, the longer for them to do their task. And also make sure to put the most important as well where the users already is. For example, your edit button should be here. For example, the home, the insert, the draw, it's in the same part of the screen. Have you wonder why this draw is not here? It's because it's for easy for you to move your mouse there, because it's the same category. There's a similarity. The label becomes part of the target, and hence the target gets bigger. As mentioned earlier, the bigger targets can be accessed more quickly. So additionally is that this icon could add in text as well that you could click, so that there's an alternative text mentioned in WCAG. So that's the similarities of that to WCAG. In-depth activity. This in-depth activity continues the work you did on the new interactive product for booking tickets at the end of chapter 11, 12, and 15. The goal of this assignment is to evaluate the prototypes produced in the assignment from chapter 12 by using heuristic evaluation. Decide on an appropriate set of heuristics and perform a heuristic evaluation of one of the prototype that you designed in chapter 12. Based on this evaluation, redesign the prototype to overcome the problems that you encountered. So find the UX. You should be a UX problem identifier or finder now. Compare the findings from this evaluation with those from the usability testing in the previous chapter. What difference do you observe? Which evaluation approach do you prefer and why? So sometimes you actually just need to do this heuristics to test the product. So try to do a usability test with an actual user and then see if that the result of the heuristics is almost the same. Then you will save a lot of money because you don't need to do the usability testing if you found that a lot of times it produced the same result. So these are the purpose of this activity. Inspection evaluation methods are usually done by the UX specialist, often referred to as researchers or experts, who role play people's interaction with designs, prototypes, and specifications. The analysis provides information about how a product is used, for instance, how different versions of a website or prototype perform, or which parts of a website are seldom used, possibly because of poor usability design or lack of appeal. So this analysis that we've made in the session of cognitive walkthrough and other methods provides information how a product is used. It answers the how, for instance, how different versions of a website or prototype perform, such as in A/B testing. And then on which part of a website are seldom used, such as in analytics, where we look at how the websites are being used. So data are often presented visually so that it's easier to see trends and interpret the results. A/B testing is another form of remote testing. Fundamentally, A/B testing is a controlled experiment in which two or more dependent variables are investigated using large number of participants who are randomly allocated to the different experimental conditions. Small difference in the UX design of a homepage can, for example, be tested using A/B testing. Again, the difference of this is that it needs to involve an actual user. I mean, if you really want to get clear or useful data, so you need to have a small user, an actual user. So basically, this chapter does not talk about just for indirect observation or the method that does not require users. For A/B testing and what do you call it, pluralistic walkthrough, it requires an actual. I mean, sometimes for pluralistic, sometimes it requires actual user. But for A/B testing to be effective, you need an actual user, and you don't need to test all of them, just percentage of the user, or like 10%. Designers and researchers often find that they have to modify these methods, as they do for those described in the previous chapters, for use with a wide range of products that have come onto the market since they were originally developed. Key points: inspections can be used for evaluating a range of representations, including requirements, mock-ups, prototypes, or products. User testing and heuristic evaluation often reveal different usability problems. So user testing or usability testing in the lab or heuristic both reveal different usability problems. So these methods are useful in UX. Other types of inspection used in UX design include cognitive and pluralistic walkthroughs. Walkthroughs are fine-grained, focused methods that are suitable for evaluating specific parts of a product. Analytics involve collecting data about user interactions to identify how users use a website or product and which parts are underused. It's about recording, again, interaction. When applied to websites, analytics are often referred to as web analytics. Similarly, when applied to learning systems, they are referred to as learning analytics. A/B testing is an experimental method used to compare two or more different designs. Fitts law is a predictive model that has been used in HCI to evaluate key process sequence for handheld device. Oh my god, we are done with human to computer interaction, which is a huge topic but very useful. But we are still in the beginning. We will further research this because it's a very useful and see available trends in the future. Again guys, thank you for watching this and see you on the next video. Peace.